Hi everyone, and thank you for visiting my channel, The Vibrant Phoenix. A couple people have asked for videos on how to solve the killer Sudoku puzzles that I post, so I thought I'd make a long form video in case you're interested, and thank you for being here. I have some apps here that are going to help us solve killer Sudoku. The first thing is just normal Sudoku. In order for you to understand how killer Sudoku works, you need to understand normal Sudoku rules. So for example, you can see we have 9 of these boxes. We have 9 rows, and we have 9 columns. Well, each of these boxes must have the digits 1 through 9 only one time. Each row 1 through 9 only once, and each column 1 through 9 only once. Also, I want to point out, you can see that even on extreme difficulty, normal Sudoku will provide starting numbers for you, and then from there you go through various logical choices to figure out what the other numbers should be. Now, that being said, we're going to go ahead and open up a new killer Sudoku. If you watch my Sudoku shorts on YouTube, you'll see that I fill in every single box with all of the possibilities, and then I start doing deductions and reasoning from that. But I hope you know that that is certainly not the most efficient way to go about it, and it's not how I'm going to advise you to do it today. Also, you'll notice that something that's present that wasn't before is you have all of these dotted lines with little numbers in the corner. Now, this puzzle follows the same Sudoku rules: 1 through 9 in every box, 1 through 9 in every row, and 1 through 9 in every column. But additionally, the 2 numbers in this is called a cage. The 2 numbers in this cage have to add up to the number in the corner. The 3 numbers in this cage have to add up to the number in the corner, and so on. Now, that's why I have this last app, Google Chrome, open. I've got it to a set of numbers or possibilities for every cage. So you'll notice, for example, that 3, 4, 16, and 17 under the 2 square cages all have only one combination of 2 numbers. So 3 can only be 1 and 2. 17 can only be 8 and 9. And you'll notice as you get further down that you get more and more combinations, but there are certain numbers with only one combination, and that's going to be useful for later. So we're going to go back to the killer Sudoku, and the first thing I like to do is anything that's a sure thing. It is a surefire answer. Okay, now the most obvious ones are single square cages, like this. Well, this has to equal 7, and it can only be 1 square, therefore it must be a 7. There's also a single square 1 here, and I don't see any others. Make sure you have your notes on so that you don't accidentally input guesses. Next, I like to find cages that only have one possible combination. 3 can only be 1 and 2. A 3 square 22 can only be 5, 8, 9 or 6, 7, 9. So I'm actually going to pop that in just to help myself remember later. Here's another 3 square. That can only be those things. 24 3 square can only be those 3 numbers, 7, 8, or 9. Now, a 9 3 square is also pretty limited. It can only be 1, 2, 6, 1, 3, 5, 2, 3, 4. Now, keep in mind, these are just preliminary notes to help get us started here. Okay, so far as just surefire numbers or surefire combinations, I think we've found everything. So next I'm going to do some geometric solves. What I mean by that is you have to have 1 through 9 in every single box. And on normal Sudoku, you just take that at face value. But in killer Sudoku, where everything is based on math, you also need to know that 1 through 9 adds up to 45. So we're going to look at this square down here, and you'll see there's a cage of 7, 3, 14, and 17, and it leaves 1 square left over. So if you add these numbers, 41. That's 4 away from 45, which means this square must be 15 minus 4 is 11. And 11 can be these choices, right? Now, because 4 is already in this cage, it cannot happen again. But like, for example, let's say you're looking at this 16, and let's say this was a 4, and you're like, well, can't this be a 4? No, because it is in the same cage. So technically it follows all the Sudoku rules, but killer Sudoku has that one more rule to think of. Now we're going to do the same thing though and find other geometric solves. There's one right here, 54. That's 9 over 45, and this is the only box that's sticking out of this square. So this has to be a 9. So we're going to go ahead and mark that in. Since this is a 9, this can't be a 2. 17 minus 9 is 8. So we'll go ahead and fill this in. Remember, it can't be 4. This can't be a 7, so this can't be a 1. This can't be a 2, so this can't be a 6. And if you're not sure why it can't be a 2, look here. So these two squares must be 1 and 2. And even though we don't know which is which, we do know it's impossible for either of those choices to exist and still have a 1 or 2 here or anywhere else. So you can think of this like a flashlight, and it flashes down, and nothing in this column other than those two boxes can be a 1 or a 2. Now it also applies, this cage is in this box. So that means nothing else in this box can be a 1 or a 2. Now we have another geometric solve over here. We can solve for this by adding these 3 cages together. 36, and that's 9 less than 45. So this is a 9. If you notice when we were talking about the 1 and 2 down here, you have the same rule over here. 7 and 8 are the only two choices, which means that 7, 8 can't exist anywhere else in the column or in the box. And that leaves only 9 as an availability. 42, and 45 minus 42 is 3. And we know 3 plus 2 is equal to 5. Now, let's go back to this 9 square. If you recall, a 3 square 9 could be 126, 135, or 234. This was 234. Well, the 3 made that choice impossible. 135, the 3 made that choice impossible, which means the 9 box must be 1, 2, 6. We don't know where the 4 is going to be, so that's one of our choices. And then 4 plus 5 is 9. Now we have one of those pairs again that are the only options. We can look down the line to see where 4 and 5 might be. So this can't be a 5. And remember, this has to add up to 8. So now we've narrowed down that this is a 1 and a 7. Now we know that these two boxes need to add up to 11. And if this can't be a 5, this can't be a 6. So it can only be 5 and 3, so we can get rid of 8 and 9. So now we're going to go ahead and fill this in. 1 and 7. And then if you look up, that has an impact on this. Now we know this is a 2 and a 1. This is a really great puzzle for introducing geometry solves, because that's going to be something that really gets you started in Killer Sudoku. In fact, without it, I think a lot of times you're going to feel completely stuck. So I think geometry is the main secret to at least getting a puzzle started. And after that, just understanding some of those logic things I explained, like singling out the pairs that to go together. How about we come up here? So we can solve for this because we can figure out the total of this is 53. 53 is 8 over 45, which tells you that this box is an 8. When you get done with actual surefire geometric solves, you can also get to some, they're not solves, but they help you eliminate some choices. So here's a really great example of that. You know that this is an 8, and if you add that to 12, you get 20, and 10 plus 20 is 30. Now, if you notice this cage and this cage are sticking out, so however much over 45 it is, which is 46, 54, it's 9 over 45. That means this box and this box must add up to 9. So we're going to turn on our notes. Now, we can also do some solving here. We know it can't be a 1, which means it can't be an 8. And it can't be a 2, so it can't be a 7. Also, because this has to equal 8, we know this cannot be a 4 because it wouldn't follow the rules of Sudoku. And this can't equal a 5 because it has to add up to 9. There's a geometric solve that you can do one of two ways. You can either figure out how far away from 45 you are by adding this together, or you can figure out how much over 45 you are by adding this together. But if you do this one, then you have to make sure you subtract 9 because this is outside of the box. So you would be adding 10 from this cage and not 19. Now, to keep it simple, I'm going to stay up here. So it means this must be a 6. Now, if you follow this down, that means this must be an 8, and this must be a 3 because it had to add up to 11. So you can see from what we've done so far that you don't have to know a lot about Sudoku strategies because there is a lot to know there, but you can still get a lot done with just geometry. And that's one of my favorite things about Killer Sudoku, is trying to find creative ways to solve problems. We can figure out the sum of this right here. So if this had to be 45, then two rows must add up to 90. And then however far away this is from 90, that's what that sum must be. So that is 7 under 90. That means this has to add up to 7. And 23 minus 7 is 16, so the rest of it has to add up to 16. Now, according to Sudoku rules here, let's see, this can't be a 3, therefore this can't be a 4. Let's look at this 22 again, because it can only be a couple choices. 5, 8, 9. Also, I want to point out that 5, 8, 9, and 6, 7, 9, those are the only choices of 3 numbers, and each one has a 9 in it. That means that this row, the 9 must be in this cage. Now that's very helpful. You know the 9 can't go here. Because you know that it doesn't, you can make some eliminations. Additionally, you know that 9 cannot go here because it must be in that cage. So why don't we go ahead and finish out this box. Oh, here's a geometric math one. So they're a little bit farther apart, but you can see that there's a straight line going down right here. And those 2 cages stick out. So we're just going to add them together. So it is 107. Now it has to be over 90. So 17 over 90, 17 can only be 8 and 9. So now we know this cannot be a 5 or a 6 or a 7. It can only be an 8 or a 9. We know this can only be an 8 or a 9. Well, knowing that, why don't we go ahead and get in here? Okay. We know it can't be an 8 or a 1. It can't be a 7 or a 2. It can't be a 6 or a 3. That means it can only be a 4 or a 5. Therefore, this can't be a 5. This can't be a 3. This can't be a 4. I'm pretty sure it had to add up to 9. So now you can see 6 and 3 are singled out. And there's nothing in the column to eliminate, but we could eliminate in the box here. This can't be a 6. This can't be a 6, therefore it can't be a 5. And that leaves this. Okay. Why don't we go ahead and solve this? Hello, baby. I don't know if you can hear it, but my kitty has come to say hello. Yes, she's very sweet. So what can we do now here? Let's see. I think it's 7. So this can't be a 5 because of over here. 5, 8, 9 are the only choices. So since this can't be a 5, therefore it can't be a 2. Can't be a 5, therefore it can't be a 2. All right, let's take a look at this 17 here. This square is missing a 2, but these 2 boxes cannot be a 2. Therefore, this must be. Now that means it adds up to 15. And it looks like we're missing 6 and 9, but this can't be a 9 because of the 9 over here. So this is a 6 and this is a 9. And if you look over here, that means this is a 1. Okay. So this 2, 6 meant that we can make some eliminations on this 6. Because 6 doesn't tend to have that many choices. It only has 2 combinations, 1 and 5 or 2 and 4. Okay, now that means this must be 1 and 5 and this cannot be a 5. So we can make that elimination. And again, look how much progress we've made without making many notes. We haven't filled out the whole puzzle. Okay, well, let's finish out this box then. So 12, but remember, the 6 is impossible, but these are the only choices there, right? Then we're going to go through this box and do eliminations. So we see a 9. That means it can't be a 9 and it can't be a 3 because it has to add up to 12. Let's see, it can't be a 5 because the 1 and the 5 must go here. And since it can't be a 5, it can't be a 7. And that means it must be 4 and 8. Then we can use that to eliminate and see what's possible in this 10. And I'm pretty certain that's going to give us a solution for one of these. So you have the 1, the 2. You do not have a 3 or a 7. Now, that means this can't be a 7 and it must be an 8. 19 minus 6 is 13. That leaves us these choices. So I'm going to do 4 and 9 taken out of the equation. And then 6 and 7 is taken out for 2 reasons. 1, because 6 is already in the cage. And 2, because of the 7 here. Now that leaves 5 and 8. There's another addition solve here. So if you can see, there's a straight line of cages that ends here. And then these 2 dip into it. So if you added up all the cages over these 4 columns, you'd see how far away it is from 180. So that means this has to be adding up to 8. That eliminated something. Again, there's no 0, which means this must be a 5, this must be a 3, this must be an 8. Now this is a 2, this is a 6, this is a 3. We can narrow this down, so now we're going to get rid of the 6 and the 7 and the 8, which leaves behind 9 and 1. And there's no vertical eliminations. Okay, now that does mean we can figure out what this 12 is. 1, 2, 3, 4, 5. And that's it. 3, 4, 5. 3, 4, 5. Okay, why don't we figure out these last 3 over here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's actually very helpful. So we know that 3, 5, 8 must go here. And that means this cannot be a 3 and this cannot be a 4. That means this must be 1 and 6 and add up to 7. So this cannot be a 6 and this cannot be a 7. Now we know this must add up to 11. We know it can't be 8 and 3 or 6 and 5 or 2 and 9. So it must be 7 and 4. And then this must be 2 and 9. Now, if we go outside of the square, you'll see there's actually a lot of solving. So this is a 9, and this is a 2, and this is a 4. This is a 7. This is a 5. Here's something that it's not such a big deal in this one, but this is a trick that you should look out for all the time. If I highlight my 5s, you'll notice on the top left there that a 5 must go in one of those 2 places, which means that anything else in that row can't be a 5, which means I can get rid of this 5 and this 5, and that this must be a 5. And you'll notice that gets rid of this, and that gets rid of this. This can't be a 7. This can't be a 7. This can't be an 8. Therefore, this can't be a 6. This can't be a 9. So this can't be a 5. Sometimes I will go through a box and just explore what the choices are. So for example, a 17, like this one only has 2 choices, right? 17 minus 9 would be 8. 17 minus 8 would be 9. So if we have a 9, then we have to add up to 8, which would only be 5 and 3. If we had an 8 and we had to add up to 9, then it would only be 6 and 3. So in both scenarios, this has to be a 3. And actually, I'm just realizing this. If you highlight your 3s, 3 can only go in one place in this box anyway. So one of you was probably screaming that already. Now, knowing that this is a 3 and this has to add up to 14, we can have 8 and 6 or 9 and 5, but this cannot be a 9. There's a little mistake here that I didn't catch before, which is that cannot be an 8. 21 minus 3 is 18, and 18 can be all choices. Now, we know it can't be 5, 8, 3, or 1 based on the fact that that's in the box with this cage. So 5, 8, 3, 1 are impossible. And then we're going to look horizontally, so it doesn't look like there's anything stopping this. And then we'll look vertically here. Can't be a 9 or 6. And this one cannot be a 2. Also, we know that this must equal 10. It cannot be 8 and 2. Cannot be 9 and 1, and it cannot be 7 and 3. Now that means it must be 6 and 4, which means you can eliminate the 6 and 4. And then since these must be 7 and 2, you can eliminate the 7 here. I'll solve that in just a moment. Let's finish the 6 and 4. This can't be a 4 because these must be 6 and 4. And then this won't be able to be a 3. And since this can't be a 9 and it must be an 8, that means this adds up to 11. And I believe this would be a 6. So in doing that, we were able to solve a great deal. I'm going to go ahead and punch these in now. 9, 5, 6, 8, 9, 3, 7, 3, 4. And then look over here, we were able to solve these as well. 8 and 5. Okay, now we've got one more box to fill in. I think I'm going to start with the 11. Can't be 9 or 2, or 5 or 6, according to the box and the vertical elimination. And then if we look horizontally, this cannot be a 3, so this cannot be an 8. All right, so it must be a 2. That's cool. That means that this adds up to an 11. Oops. Oh, this can't be a 7. And it can't be a 4. There you go. So you have 2, 6, and 5. Let's go ahead and fill those in. And you can see that sort of chain reaction in terms of solving other things, because we're almost done. If we're dealing with this 12, it has to be a 7 or an 8 in this box. And then here, it looks like we're missing a 1. Oops, a 1 and a 3. 4, 5, 6, 7, 8, 9. Okay. Now that means this must be an 8. And there you go. And now we're done. Thank you for watching today. I'd love to know what kinds of Sudoku content you'd like to see next. So comment below and let me know. Take care.